Every year, cargoes of liquefied petroleum gas and liquefied natural gas are transported on hundreds of very specialized liquefied gas carriers throughout the world. The number of fires involved in the conveying of these cargoes, whether sailing the oceans or whilst loading or discharging at terminals, is commendably extremely small. And this record can be maintained by a continuance of the efficiency and maintenance of the equipment, together with the thoroughness of the training, the emergency planning, and not least, the vigilance and expertise of the crews. Nevertheless, leakages of liquefied gas can occur from time to time, and some of these could be followed by ignition and consequent fire. It is the purpose of this film to deal specifically with the procedures developed and proven for the control and extinguishment of liquefied gas fires, as distinct from fires in, for example, the accommodation or engine room, which will be tackled in the conventional way and in general extinguished in accordance with the nature of the fire, whether by water, foam, dry powder, or CO2 or halon. We will first deal with the basic emergency procedures taken when a fire is discovered.
Detector bridge, fire at port manifold.
Later, we'll go into the reasons for some of the actions to be taken and the characteristics of the incident.
Control, that's the blue party mustard. Yours okay, Tom? Blue party mustard, aye. Red party mustard.
Liquefied gas fires are of two basic types: liquid pool fires and pressure fires from escaping gas, probably with the pressure increasing from the heat of the fire. But whatever the fire, the old maxim, find, inform, restrict, extinguish, still applies, although some of the means of informing, restricting and extinguishing have advanced immeasurably. The first essential upon finding is still to raise the alarm, so everyone must know beforehand where alarms are situated and what procedure is adopted on their particular ship. As part of informing, the bridge and engine room or the cargo control room must be given immediate information about the fire. If alongside, the terminal will be informed immediately by the ship using previously agreed means of communication in accordance with the pre-planned emergency procedures. The next action that will be taken is to restrict the effects of the fire. Whilst the emergency crews are mustering, the spray cooling systems will be activated to cover the areas which could be affected by the fire and for protection of the accommodation.
Come in, John. Come back, Tom. That's spray valves 2, 4, 5, now open.
The fire water pumps, if not already running, will be started up immediately to maintain pressure in the fire main. The terminal, upon being informed of the fire, will activate its own water spray protection, covering vital areas of the pipelines and the hard arms. Some terminals have water curtains which operate as you see here. At the emergency control center on the ship, the master is in charge of operations, and in liaison with the terminal control, emergency shutdown will be activated. This is done with due consideration to the prevention of surges in pressure in the transfer pipelines, both at the terminal and on the ship, and according to the product, and whether loading or discharging operations are taking place. Meanwhile, the emergency crews are finishing preparations. The suits are prepared, ready for them to step into without delay. The trouser legs already tucked over the boots. The fire crews will be wearing heat-resistant protective clothing, which can enable them to work in conditions of considerable heat. Some will be donning breathing apparatus in case it is necessary to work in an area where there may be gas or toxic fumes. The master is receiving information about the supposed fire. The first emergency crew is on its way to the scene of the incident. This being a drill, of course, not an actual fire on board. The hoses are being run out. The master, from the information he's received from all quarters, has assessed the situation of how to tackle the fire and has ordered that any isolating valves to the pipelines which may be feeding the fire should be manually closed. All the actions so far taken are to restrict the effect of the fire. One, by cutting off the supply of gas to the fire as far as possible, and two, by cooling the surrounding area. These actions will in general apply to a pool fire or a pressure fire, or a combination of both. We are now seeing a flame impinging on a pipe and flange. This is not on a ship. It is at a training college where all the fire sequences were filmed. Now, how should this type of fire be tackled? It will mean making an assessment of whether to extinguish the fire or whether to control the flames until the fuel source has been isolated and any residual gas has been burned away. To appreciate fully the factors which determine whether to extinguish or control, it's necessary to consider some of the characteristics and properties of LPG and LNG. What you see here is liquid propane evaporating into gas. Obviously, there is a much greater volume of gas than there was liquid. But how much more? If the dot you now see on the screen were liquid, it would expand to about 300 times that volume of pure gas. But the gas will mix with air, and the resultant flammable mixture may be 1,000 or more times the volume of the single drop. We're seeing the cloud as if from above. There is another factor which affects where the gas will flow, the density. LPG is heavier than air, at ambient temperature typically about 1.5 times heavier. On this model of a ship, we're simulating a gas escape by means of a chilled mist, so that the movement can be seen. As you see, the gas does not just rise and disperse. Some may be carried up by eddy currents of air when it meets obstructions. But most of it flows along the deck, finding the lowest levels. And therein lies the danger and the need to carefully assess whether to extinguish or control. Remember, too, that the gas in a real escape will spread further than any visible cloud, which is condensed moisture from the air. The gas itself is invisible. LNG and ethylene spills are, because of their low temperature, initially heavier than air. Ammonia will react similarly. Now watch this simple experiment. We pour into a container a small quantity of liquefied gas. We know that the gas must be flowing down the tube and combining with air as it goes. An ignition source is introduced, and there's the result. A flashback to the source, and all around, flames igniting any carbonaceous material in the area. Let's look at the end of the experiment in slow motion. First, we see the initial rapid flash, which is the burning of the outside of the cloud, where the gas is well mixed with air. Then there follows a slower burn of the richer gas. Very good reasons for keeping upwind of any escape. Now let's see something of the layout of gas carriers and the installations in the light of what we've just seen. We're looking particularly for possible areas from which leakages may occur. We can see the most vulnerable points. The manifolds, flanges, valves, pump seals, bellows, gauges, domes, compressor rooms. We're seeing them on different gas carriers, but the potential dangers are the same. We now have an extension of our laboratory demonstration and relating very closely to the problem of firefighting on liquefied gas carriers. Here we have a small but actual pressure fire. Whilst the flame is burning, there is no gas in the area around. An explosimeter shows the area is safe. Nothing ignites if we introduce a lighted taper. Now we extinguish the flame, but still allow the gas to pour out. The meter shows the gas is spreading in the area, and when the ignition source is introduced, flashback occurs. Let's look at part of that again, as it so vividly demonstrates the logic of controlling, not extinguishing, as a general rule. Having seen those demonstrations, we come to the question of how to control a pressure fire in order to minimize the damage it may cause by overheating other parts of the installation, particularly those containing liquefied gas. If heat from a fire raises the temperature of exposed steelwork above 400 degrees centigrade, it begins to lose its strength. The actual temperature depends on the grade and composition of the steel, and distortion may occur at even lower temperatures. In any case, because of the heat, the pressure in the pipe will be greatly increased. The result may be a rupture of the pipe, with a sudden release of a quantity of gas which could produce a large flame at high temperature for a short time. One of the things we must avoid by controlling the fire and by cooling surrounding steelwork. So back to how do we control the fire and keep it from heating sensitive areas. We can assume that the emergency shutdown has stopped the flow of gas through the pipelines. Now, in order to control that pressure fire and prevent overheating, we must divert or bend the flame away from the danger area and preferably out into free air. By this technique, a flame can be bent to an angle up to 90 degrees. Here you see the flame bending operation at the training college. As you see, the spray is formed by adjusting the nozzle from jet to fine spray. The spray is then brought round and gradually bends the flame away from the danger area. Let's look at that again, as it is so very important when dealing with liquefied gas pressure fires. Care is needed to avoid extinguishing the flame accidentally by directing the water spray at the base of the flame, as if it is extinguished, we have the problem we were trying to avoid, an unignited gas cloud. Two crews will normally be employed, working side by side, and each crew will consist of a nozzle man and a backup man to resist the back pressure from the spray or jet. A fifth man should be used to keep the hoses free from kinks and obstructions. These techniques should be frequently practiced on board. Approaching a terminal and before operations commence, it is a requirement that two hoses are laid out on the ship. These will be the first used in an emergency, and further hoses will then be run out as backup. Fixed dry powder installations are also available. In the event of the need to approach a valve which is surrounded by fire, in order to cut off a gas supply to the fire, water curtains can be formed and used to protect the person who will attempt to close the valve. Again, two hoses will be used and must be held steady. The person, as you see, approaches between the hoses, and when they're carefully positioned and the valve is sufficiently cooled, he then closes the valve, taking care not to penetrate the curtain. A point to note is that when the fire is approached and the water wall is closed down slightly to produce a cone to push the flames away from the emergency team, the vortex may cause the flames to funnel towards the center of the cone in the direction of the nozzle man, who must hold his ground and not back away. One word of warning. Despite what we've shown of the possibilities of controlling pressure fires, never attempt to ignite a leak with the idea of then being able to prevent the spread of gas. Igniting the leak would be likely to cause a dangerous flashback and could escalate the situation. Pool fires, if they occur, may be dealt with either by allowing them to burn out once the spill has been arrested, or alternatively they may be extinguished, providing the remaining liquid can be dispersed when it boils off. If there is a pool fire and a pressure fire, and it's decided to extinguish both, the pool should be tackled first, working to the pressure fire where the leakage has taken place, or is still taking place. Water jets must not be used to attempt to extinguish a pool fire. See this demonstration of water being played on a drip tray containing burning LPG. Water should not be used on an unignited pool of liquid gas, as the liquid gas will boil up and spill and spray around. On the skin, the liquid can cause severe cold burns. If the liquid is LNG, it is capable of cracking the ship's deck. Incidentally, a fine jet of water has been used effectively under exceptional circumstances to cut through at the base of a pressure fire at the point of leakage and extinguish it. But a point to remember, the water may freeze after extinguishing the flame and seal the leak, which may burst through later and cause a fresh problem. Medium or high expansion foam may be effective in reducing pool fires and is one means of tackling a gas fire in an enclosed space. But the best extinguishing medium for liquefied gas spillage fires is dry powder, which absorbs the energy in a flame and stops the chain reaction of combustion. The technique you see here, working with sweeping movements from the front to the back. What has to be borne in mind is that the powder settles to leave behind flammable liquid and vapors, which, after the flame is extinguished, may be reignited by adjacent hot surfaces. Therefore, a considerable amount of powder may be required. In the case of a large area of fire, it may be advisable to delay operations until backup material is available in sufficient quantities to extinguish the fire in one concerted attack. It is here that the fixed dry powder installations come into their own. As a last resort, water fog can extinguish a pool fire, but once again the whole flame has to be engulfed, which is difficult in windy conditions. But now look at the effect of dry powder in a similar situation, so quick and efficient. However, if it is decided to tackle a pressure fire with the object of extinguishing it with dry powder, a definite technique has to be employed. If the powder is directed straight at the fire, or at right angles, it may not extinguish the fire. The powder has to be entrained into the gas jet and flame from behind, as you see here, to put out the flames. Masthead vent fires can occur, and majority opinion believes that such fires should only be extinguished by cutting off the fuel, as in this way the danger is avoided of quantities of gas engulfing the vessel. Extinguishing by means of injecting a plug of nitrogen or CO2 up the riser can be used. The principle you see in action in this miniature mock-up, which also demonstrates that it is essential to cool the area around the flame, as otherwise reignition is almost certain to occur. The quantities of nitrogen or CO2 required are very considerable and couldn't possibly be supplied by portable extinguishers. Perhaps the most important factor in all firefighting is readiness for emergencies, and this can only be ensured by regular drills encompassing the special requirements of the gas carrier. These drills should be carried out with full protective clothing, so that crew members become accustomed to donning the clothes smoothly and rapidly, and so that they become used to them when handling hoses and equipment under difficult conditions. All crews must be familiar with the wearing and operation of breathing apparatus, and the equipment tested regularly, the air bottles fully charged. Extinguishers must be checked regularly, even if they haven't been used, and all equipment must be maintained in fully operational condition at all times.
Both fire parties ready, they're proceeding on to deck now. Okay, that's all.
Much of what we've dealt with in this film about fighting LPG and LNG fires is applicable to firefighting procedures at terminals, as well as on board. Terminals themselves have stringent safety standards and regulations with laid-down emergency procedures. And before a gas carrier is allowed to enter port or berth, and also before any operations may commence, comprehensive pre-arrival and ship-shore checks have to take place.
Oh, John, next time we go on board for the figures, will you just check on that back pressure on it?
On arrival, a representative of the terminal will come aboard, and an internationally recognized ship-shore safety checklist will be jointly completed. This is a thorough check, and it is the duty of all concerned to ensure that what they are signing represents the true position on board and on shore.
Okay, thanks very much. Back on the channel 2.
Various officers will double-check, if necessary, that the procedures have been carried out, and the checks must be thorough and correct before signing. Points covered include the emergency procedures, communications between ship and terminal, and the functioning of the emergency shutdown. Some terminals have a cable which is connected into their emergency shutdown system and run out with a pendant to the ship. This is an emergency arrangement enabling the ship to activate the shore emergency shutdown in ship loading operations. In ship discharge conditions, a similar cable is sometimes run from the ship to the shore so that the terminal can activate the ship's ESD. If a fire does occur on a vessel moored at a terminal, the emergency shutdown will be operated almost immediately in accordance with the previously agreed ship-shore procedures. Terminal installations often have sensors incorporated in the system and surge tanks to avoid excess pressure from surges during the shutdown. After the sounding of the alarm, as we saw earlier, the terminal cooling sprays and water curtains, if fitted, will be activated. These frequently cover any emergency surge prevention tanks, as well as other vital parts of the installation, and of course would also provide protection to the ship if there was a fire at the terminal. At many ports and terminals, firefighting tugs and other firefighting resources are available and provide useful cooling capabilities. Normally, in the case of fire, the procedure, if possible, is to disconnect the hard arms after clearing. On many installations, a rapid release mechanism is provided for this purpose. To summarize the most important points discussed in this film on firefighting procedures for gas carriers. Raise the alarm. Inform, and if the ship is at a terminal, the fire will be reported immediately to them as well. Simultaneously, activate the fixed cooling systems. In liaison with the terminal, the emergency shutdown will be activated. Take action to isolate the source of the fire. Bearing in mind the danger of extinguishing a pressure fire whilst gas is still escaping, assess whether to extinguish or control, whilst cutting off the supply to starve the fire. Know the procedures to be followed on your ship. Keep calm. Be definite about actions to be taken even when close to the heat of the fire. And that way you can prevent an incident from escalating. As we said at the opening of this film, gas carriers have an excellent record where fire is concerned. And this is not a matter of chance. It is the result of constant vigilance, thorough training, and conscientious and professional operation by all. See the film again and read the support documentation. The knowledge of what to do at the right moment, everything properly maintained, and the strict following of procedures have already resulted in an overall excellent record. It should be the goal of everyone, in the interests of all, that this excellent record should not only be maintained, but improved.